Okay, Assalamu alaikum and a good afternoon, everyone. So today we have another session of your presentations. So today we only have two presenters because the last presenter will be postponed to, I think it's 22nd June or something. Okay, but today we have the first presenter, Fatma Ali, who will be speaking on synthesis and superconducting properties of bulk YBCO superconductor by method of thermal treatment, the role of addition of CNT, silicon carbide, titanium oxide, nanoparticles. So please proceed.
Okay, thank you, Prof. Assalamu alaikum and good afternoon, Prof. Hisham Al-Din and my classmate. I'm Fatma Alfirgani Barood, a PhD student at the Laboratory of Superconductor and Thin Film under supervision of Dr. Mohad Mustafa Aoun Kashik. Today I'd like to present my final seminar with the title of Structure and Superconducting Properties of Thermal Treatment Synthesized Bulk YBCO Superconductor, the role of the addition of carbon nanotube, silicon carbide, and titanium oxide nanoparticles. This is the outline of my presentation for today. For the introduction, I would like to explain a little bit about the superconductivity. So superconductivity is a phenomenon in which the electrical resistivity suddenly drops to zero at its transition temperature. Superconductor has the ability to exclude weak applied magnetic field as the temperature decreases through the transition point. This called Misener effect, as the superconductor can be levitated above magnetic using this effect. So one of the most existing development in modern physics has been the discovery of high temperature superconductor conductivity in copper oxide with critical temperature around 35 Kelvin. So this followed by the discovery of YBCO by Cho, which was the first to show superconductivity around 77 Kelvin. This compound named YBCO or Y123, which belong to the type 2 of superconductor. YBCO is attractive materials of high temperature superconducting family because its higher value of critical conductivity parameters such as critical temperature, critical current density, critical magnetic field. This is the structure of YBCO. The structure is oxygen deficient perovskite and have layered structure of copper oxygen planes and chains arrangement. The layers are separated by CO2 plane with diaphragm between the CU plane and chain. The planes made up of oxygen bridge square lattice of copper atoms and parallel to the CO2 chains, while the barium atoms are arranged between the chains and planes. The superconductivity in this compound originates from the copper oxygen planes. For the problem statement, first problem is the complicated procedure, long reaction time, and high cost of high temperature superconductor synthesis methods. Second problem related to the critical current density that makes the superconductors attractive for power application, which is the ability to carry current without losses. However, JC or critical current density greatly depends on the microstructure property of high temperature superconductivity due to high anisotropic layers in their structure. So, in the presence of applied magnetic field, the dynamic of vortices is the major causes of energy loss. And hence, this is lead to reduction in JC. Also, the value of oxygen content found to depend on the oxygen, the value of TC found to depend on the oxygen content that is not stable in YBCO system. So use this material for large-scale application requires sufficiently high critical current density and high magnetic field. This can be achieved by using thermal treatment method. This method has the advantages of simple method and low cost and short reaction time, and it's also environmentally a friendly method since it uses less chemicals. So also the enhancement of superconducting properties of YBCO can be by the addition or inclusion of nanoparticles. So the addition of non-superconducting phases into YBCO can be useful way for enhancing the flux spinning and improving the JC value. So the objectives of this study is to synthesize Y123 bulk through thermal treatment method with BVB as keeping agent, and to synthesize the phase of Y123 bulk added with different composition of carbon nanotube, titanium oxide, and silicon carbide nanoparticles via thermal treatment method, and then to investigate the effect of carbon nanotube, titanium oxide, and silicon carbide nanoparticle addition on superconducting properties of Y123 superconductor. Finally, to study the microstructure and morphology of Y123 added by different percentage of these nanoparticles. This some of previous literature review. In 2020, Hanashi was studied the effect of carbon nanotube on YBCO bulk using a solid statement method. He found that TC was increased and the JCM also was increased by this method. And in 2015, Rajat studied the effect of titanium oxide on YBCO bulk by using solid statement method. He found that the TC was decreased while the JC was increased by titanium oxide addition. Also in 2016, Dardas studies the effect of silicon carbide in YBCO bulk by using gel method. He found that the critical temperature decreased, and while the JC was increased, and the grain size was small, about 0.2 micrometer. For the methodology, this is the starting materials we use in this study: yttrium nitrate hydrate, barium nitrate, copper nitrate, BVB, and the addition is a single walled carbon nanotube, titanium oxide, silicon carbide nanoparticles. So, the sample were prepared by thermal treatment method. The starting materials were weighted according to its ratio to form YBCO 1, 2, 3 phase. Then 6 grams of BVB was added to the 300 milliliter of deionized water. The nitrate solution was then stirred at 80 Celsius for 2 hours. The solution dried at 110 Celsius for 24 hours to evaporate water until we finally get solid like gel, green gel. So the gel ground for 1 hour. Then the powder was precalcined at 600 Celsius for 4 hours. The powder ground again for 15 minutes, then calcined for second time at 910 for 24 hours. The powder reground again, and the addition of nanoparticles were done during the pelletization process. Finally, the powder was pressed into pellets and centric at 980 Celsius for 24 hours and held for annealing at 650 Celsius for 12 hours in oxygen atmosphere. Then the sample is sent for characterization. we use XRD structure for structural properties, alternative current susceptibility for superconducting properties, EDX for element composition, FISAM for surface morphology, and 4-point probe to measure JC and TC. ESR for magnetic properties, and TGA for thermal stability. Now let's move to the result. This is the XRD result for YBCO with carbon nanotube addition. The figure shows the YBCO pure and carbon nanotube added samples. The single orthombic phase of Y123 is confirmed, and the major phase of Y123 was found in all samples. However, there were a few peaks referred to Y211 and Y247 secondary phases. It can note that the intensity of the peak in 0.4 carbon nanotube addition was increased, where the crystal peaks clearly originated along the C-axis. Also, it was no significant change in lattice parameter ABC, while the orthohompicity gradually increased as the addition of carbon nanotube increased. And also the addition of carbon nanotube increased the oxygen content, which was calculated using this equation. And the crystalline size also was decreased with carbon nanotube addition. This is due to the formation of secondary phases in the compound. Now, XRD for titanium oxide addition. The figure shows XRD patterns for pure and titanium oxide added YBCO samples. The analysis indicated orthorhombic Y123 structure for all samples with small amount of Y211 secondary phase. Therefore, no peak related to titanium oxide was observed and seen. That also we can say that the titanium oxide didn't enter the YBC structure. The lattice unit cell increased with, and the orthohompicity also increased for all samples, and crystalline size was decreased, and the conductive oxygen was decreased also for all the samples. And this is XRD data for YBCO with silicon carbide nanoparticles. The figure also shows the major phase in this was Y123 beside a small amount of impurities, Y211. And it's noted that there were broadening in the peak with the samples of 0.8 and 1 of silicon carbide nano addition. The crystalline size and the orthohompicity was decreased, especially for a high percentage of silicon carbide addition. This is maybe because the silicon carbide nanoparticles prevent the growth of YBCO crystallite in these samples. For AC susceptibility, we can measure the transition temperature. So this graph shows the real and imaginary parts of normalized AC susceptibility. From the real part, we can obtain the diamagnetic transition of YBCO bulk, as we can see, to double transition due to the weak links. These behaviors of superconductor, the transition becomes steeper with 0.4 carbon nanotube addition, which means the reduced weak links and the stronger interconductivity between the green in this sample. TC onset, and which can be defined as the temperature at which the resistance begin to drop. TC onset increased for all samples, and the highest value was for 0.4 carbon nanotube addition was 92.3 Kelvin. And from the imaginary part, the sample exhibited only one peak related to intergreen peak, the intercoupling peak, which present AC losses shifted toward the higher temperature for the samples of 0.4 and 0.8, then slowly shifted to lower temperature for other percentage. The intergranular critical current density JCM was calculated using Payne's model and was around 2 ampere per centimeter square for 0.5 Ørsted applied magnetic field. The maximum Josephson and Josephson energy was increased for all the samples. This is means enhancement of the intergranular coupling among the greens with carbon nanotube addition. And this is IC susceptibility for titanium oxide addition. The IC susceptibility measurement done at applied field 5 Ørsted and frequency 295 Hertz. So from the graph shows the real and imaginary parts. From the curves, we can the superconducting transition temperature of the green does not change greatly with the titanium oxide addition, and the highest value was from for 0.6 with 96 Kelvin. And TCG and J and TC onset can be determined by this graph. The intergranular loose peak become lower, as we can see. This is for the pure, and this is for the addition. This peak will become lower with titanium oxide addition compared to the pure one, which may be indicated enhancement on flex trapping and green coupling. The intergranular critical current density was around 21 ampere per centimeter square, and Josephson current and Josephson energy was also calculated in this sample. Now let's move to for ICC stability for silicon carbide. I'm still waiting for the result that I didn't include the result. So for now electric resistance measurement, this is the electric resistance for carbon nanotube addition. The graph shows the normalized resistance varies temperature. All samples shows metric normal state behavior above the onset transition temperature. The normal resistance were decreased for all samples. Expected for the sample with 0.2 carbon nanotube addition. The superconducting transition temperature, TC onset and TC0, for all samples was decreased, while the transition width, we can get the summary of TC onset and TC0 show increase in the value, and also the transition width was increase for all the samples, but except for 0.4. The whole concentration increase for all samples. This increase may be due to the carbon nanotube addition, which result in the formation of additional hole carriers in Y123. Next, the electrical resistance measurement for YBCO with titanium oxide addition. The measurement done with 4-point probe method. As we can see from the graph, all samples show metric behaviors in the normal state, followed by the sharp transition to superconducting state at TC onset. The resistance decrease for all samples. Moreover, there was a reduction in TC onset, as we can see, and TC0 for all samples. This is expected due to the formation of impurities. The narrowest peaks were found for samples with high percentage of titanium oxide, 0.6, 0.8, and 1 titanium oxide addition. This is indicating optimum oxygen content in these samples. And here the summary of superconducting transition TC0 and TC onset. There were and also the whole concentration, which was increased for 0.8 titanium addition. The transition was improved for high concentration too, as we can see, 4 and 3. This is the electrical resistance measurement for silicon carbide with carbon nanotube with YBCO addition. So as we can see, the pure and silicon carbide added YBC sample show the matrix behavior in the normal state above the TC onset. However, the addition of silicon carbide for the sample with 0.8 and 1% silicon carbide affected the matrix behaviors that finally exhibited semiconducting like behaviors. This is also can be seen from this graph. The peaks is very low and in these samples, while the narrowest peak was for the sample with small addition 0.2 silicon carbide nanoparticles. The TC onset and TC0 was determined and was decreased for all samples, and the whole concentration also was decreased except for the samples with 0.8 percentage. Okay, for transport critical current density, the critical current density we used 4-point probe to measure the critical current density or the critical voltage current voltage of the samples. And so far, the samples with carbon nanotube addition were measured, and for the pure sample, is still waiting for the result. This graph is plotted to determine the critical current value, which used to calculate JC. From this, we can see that the JC was increased as the percentage of carbon nanotube increased and was high for 1% of carbon nanotube. For FISAM, and this is the FISAM and EDX for pure YBCO. The centered powder show granular structure consists of micrometric green and have different average green size with some voids and holes. The average green size was determined from 100 greens and was around 1.2 micrometer for pure sample. EDX of pure YBCO show the elements weight and atomic percent, the peak corresponding to YBCO also observed for this sample. And this is the FISAM for carbon nanotube, and for the addition, I will go quickly because the time for titanium oxide and silicon carbide, and also EDX for all the nanoparticles. And to conclude, the addition of nanoparticles results in filling of voids between the greens. Hence, reduce the pores and make the greens boundary display strong connectivity. So also the EDX spectrum for all the samples represent Y123 for all samples. For the conclusion, we can the signal phase of Y123 superconductor Y is successfully synthesized by thermal treatment method. The effect of carbon nanotube, titanium oxide, and silicon carbide nanoparticle addition was investigated. So all patterns are assigned to orthombic phase of Y123, and the orthombicity of Y123 was increased for all addition. The crystallized size decreased for all the addition, and the average grain size for these samples around 0.4 to 3.5 micrometer. Also, the effect of nanoparticles and superconducting properties was investigated. For IC susceptibility, we found the critical temperature was increased for carbon nanotube and titanium oxide addition. The maximum Josephson current and Josephson energy was calculated or determined. The intergranular current density for all samples was determined by Bain's mode. And for the electrical properties, the onset superconducting transition temperature TC onset and transition temperature at 0 TC0 and the transition width was determined for all nanoparticle addition. The critical current density was determined for only carbon nanotube addition. So this is for future work to continue characterization for ICS and critical current measurement for titanium and silicon oxide, silicon carbide addition, and characterization for TGA and ECR. This is the references and acknowledgement. This is my Gantt chart and milestone. And thank you for listening.
Okay, thank you, Fatma. So I invite questions from your peers. Anyone?
Yeah, Prof.
Yeah, go ahead.
Assalamu alaikum. I am Madiha Fathi. Thank you, Fatma, for your presentation. I have a question related to your methodology. What's the purpose of using BVB? And why you do two calcination for your samples?
Okay. The purpose of using BVB, the BVB and this method act as clipping agent and improve the degree of crystallinity of the products through that can be through mixing of the raw materials in the prepared solution. So BVB would promote the combination of the metallic ion with the amine group present in polymeric chains through ionic dipole interactions. And in this method, yes, pre-calcination or frisk calcination allow decomposition of PVB and nitrate leaving only YBCO elements, and also promote formation of development of samples particles. And the second calcination to eliminate unwanted volatile particles and purify the products, and also enhance thermochemical oxide reaction to form the required homogeneous product. And maybe the final phase may be not form completely after calcination. That's why we follow this biosintering process.
Okay, thank you, Fatima.
Welcome.
Next, we have Ziatong. Please go ahead.
Yes. Thank you for a very good presentation, Fatma. And among the carbon nanotube, the TiO2, and the silicon carbide. You think that among these three, can you hear me?
Sorry, I stopped. Okay.
Okay, can you hear me, Fatma?
Yeah, can you repeat your question?
Okay, so among the particle addition that you add is the carbon nanotube, TiO2, and silicon carbide, right?
Mhm.
Among these three, you think that which element that you add have the best performance in your opinion?
Okay, according to the result I have, I think carbon nanotube was the best nanoparticles because from the result we see okay, the TC increased for our samples and also from electrical from transport critical current density, we see the JC was increased. I really maybe I cannot decide now. I need to measure the JC for titanium oxide and also for silicon carbide. The best or the high amount of the highest JC, the highest JC of which nanoparticles. This is what can I decide. This is which nanoparticle is best.
Oh, okay. Thank you for your answer.
Yeah,
Thank you.
we have another question from Lao Yinjian. Yes, go ahead. Lao Yinjian. Okay, I think you've typed. Okay, it's in the chat box. So the question is, what is your expected result for TGA after additive addition?
Okay, for TGA, I haven't done the characterization yet, but for our purpose, we do TGA only for pure powder of YBCO.
So not for the with the
For
additive.
not for the addition, yeah, to determine which sintering temperature we use for this compound.
Okay, is that okay for the answer, No Yinjian? Okay, so I think we should move on to the next presenter. So next presenter will have Caceja Elyca.
Yes.
So please share your slides, please.
Wait.
By the way, Caceja will be presenting her proposal seminar. Okay, so it's on the application of game theory and machine learning in determining real return on investment potential of farmers by interrupt middleman market. So please.
Can I? Okay. So a very good evening to Prof and my other colleague. So today I will present my research proposal in the title of application of game theory and machine learning in determining real return on investment (ROI) potential of farmer by interrupt the middleman market. So my name is Caceja Elyca Bundak. My metric number is GS63639. My supervisor is Dr. Muhammad Amiruddin Abdul Rahman. So here is the outline of my presentation. So let me proceed with my research, I want to attract the audience that I want to attract is the farmers. The one that I want to help is the farmers, because they often lost fair share of market prices, and most of the farmers are they get more poverty, and being they cannot generate enough income for themselves due to poor selling price of their harvested commodity due to the middleman. As you can see from the figure 1, you can see that the producer, they get less than 40% of the consumer retail price, compared to the middleman which get 43%, and the remaining is 70% consisted in different expenses. So uh, the farmer and the middleman get more than the farmer, and the reason for the loss in the harvest is because the farmer sometimes they get poor transportation, inadequate storage capacity, and most important is their poor marketing facilities. So here we can see the news from the article from the Free Malaysia Today in December 16, 2021. The Malacca Pharma Deputy Director Amir Azan Jamil says that uh, they propose to help eliminate the middlemen who eat the into the farmer earnings, because we want to allow the consumer to buy a vegetable at lowest prices and help to reduce their cost living, and at the same time we want to eliminate the middlemen, which can help the small farmer to get keep all their profits. And here's another news by Bernama 13 April 2022, where the farmers complain that they sell to the middleman a vegetable called as sawi at 1 ringgit 30 cent per kg, but in the market, the middleman sell it for 6 ringgit to 7 ringgit. So the farmers, they get not just the farmers, but not just the consumer, but the farmers, they're experiencing the concern over the rising price of the vegetable and claiming that the middlemen are the one that contribute to the problem. So who is the middleman market? So the middlemen are those individuals or business concern who specialize in performing the various marketing function involved in the purchase and sale of goods, as they are moved from producer to consumer. So as you can see from the picture, the farmer, they work so hard, but the middleman that get more profit than them. So the problem is the involvement of the middleman and the transaction of the cash crop goods between the farmer and consumer can affect the price stability. So there are maybe another contributing factor that can affect the final selling price at the consumer level, but it was subjectively determined. Another problem is there are limited number of studies have been done on price prediction for agriculture product, especially for the vegetable. And in Malaysia, especially, the trading activity such as farmer market caravan and weekly farmer market only open the market to the surrounding local. They doesn't spread their selling to other country or to other places. The unsold goods will get perish over time and can give big loss to the farmer if there are mass production of the harvest goods. And so the farmer will come back to the traditional supply chain by selling to the middleman who could buy the farmer community in bulk, and the middlemen are the trader that seek for constant revenue and increasing the profit from time to time. So what we want to help is the main objective is to limit the involvement of middlemen in the transaction of cash crop goods between the farmer and consumer immediately. So how can we help it? We want first we study the price received by the farmer and the price paid by the consumer using a computational intelligence technique, which is the machine learning. The second one is we use the machine learning to predict the final selling price at the consumer level according to those measurable factors that affect the selling price. For example, uh, like the weather and other factor, the stock production factor, like that. And lastly, we want to design an electronic trading market using a hybrid machine learning and algorithmic game theory approach. So my research question is, what are the factors influencing the selling price received by the farmer and the price paid by the consumer? I want to know what is the relationship between the reserve price between the farmer and the middleman with the selling price between the middleman and the consumer, and then how effectively to predict the future price trend to optimize the investment strategies to avoid price risk and improve investment return. And I want to know which machine learning that can apply to predict the selling price and whether the application is reasonable and superior. Next is I want to know what is the impact of the electronic trading on the community futures later, and does the online trading market apps can help open opportunity the market develop to other places and country. So here are some of the literature that doing some prediction and making a online trading market. So first one is we at 2012, they predict the agriculture product prices using the improved BP neural network. So they use it to provide an effective prediction tool for the agriculture product price forecasting. And then we have Powder at 2019. They make an apps that it's a peer-to-peer energy trading in a consumer-based community microgrid. They're using a game theoretic model. These apps can reach the stable state in the evolutionary game among the buyer and the seller selection. So next is from ZAO 2021, which improved the accuracy of agriculture product future price prediction using machine learning. They didn't mention which machine learning they use, which provide a theoretical reference for subsequent related research. Then we have Biona Oral in 2021. They use it. They make a price prediction in agriculture product using machine learning also, and they said that machine learning can help in the prediction problem, especially for the price prediction. And then we have Yuan Link 2020. They use it for agriculture commodity price prediction. They're using ARIMA, LSTM, SVR, Profit, and SG Boss, which they help farmer in sufficing their agriculture market knowledge and maximize their profit in doing farming business. And we have lastly RACRA 2031, which make a review of crop price prediction using the random forest and decision tree regression algorithm, which they said that it can improve the current situation in agriculture industry and help the farmer with getting the best for their crops. So this is my proposed method. So firstly, we collect the data set and we do a data set collection of commodity selling price by the farmer and buying price by the consumer. Next, we use the data to develop a machine learning algorithm for predicting the trading price. And we also use the data for develop a game theory technique as a binding platform for electronic commodity market trading. And we combine both it for, we integrate the machine learning algorithm into a game theory framework, which we use it to reduce the computational load of the traditional game theory technique. And lastly, we make a performance assessment of the developed algorithm that we made. So here is the data collection, the link for the data collection, which we get it from the Federal Agriculture Marketing Authority, FAMA. We also try to, maybe later we try to get other data from MARDI and also from Ministry of Trade and Industry Malaysia. But that data is still in progress. We still try to collaborate with both agency. So in here we have the latest market price, which have three type of price: we farm price, wholesale price, and retail price. So this price will be used it have a variety of places in Malaysia, and have variety of crops or foods, and we will see the high price, the average price, and the lower price in term of all the three type of price is of these three price. And we use other than the food price, we will use other kind of factors that affect the food price. For example, like stock at the beginning, imports, production, export, domestic consumption, stock at the end, industry, and food production. So this is my first trial in trying to predicting the trading price. I using the latex data set in which have some other several input factor, and then we do a data pre-processing using a correlation coefficient, and then we split the data into daily and monthly data, testing and training data set. The training data set will be uh, will be how will be used in the training data set will be trained in using the three type of algorithm that I have tried. BSVR, which is the Bayesian support vector regression, and then support vector regression particle swarm optimizer, PSO-SVR, which PSO-SVR is an SVR that using a optimizer. And then we have Arimax, which come from Arima first, the auto-regressive integrated moving average. And then we train this model, we train, and then we use the testing set to check the accuracy of the algorithm, of the prediction. And to evaluate, we evaluate the performance of the prediction. We using three type of evaluation metrics, which are the root mean square error (RMSE), mean absolute error (MAE), and correlation coefficient (CC). So this is for the prediction for the first objective, which for the prediction of market price. For the second objective, where we want to make a game theory technique based on double auction mechanism, this is the bidding platform for electronic commodity market trading. So here you can see that the buyer, they will make their own multiple bids, and then the seller will make a multiple offer, and both this they are come from any places, like from Sarawak or other country. We'll send it into an online apps in an order matching mechanism, and here we will choose which the highest buy price and which the lowest offer price, and if both buyer and seller agree, and if it match, then the trade is executed. So in terms of a flowchart of the algorithm, so here we have start, and the organizer will establish an auction rule inside, and then the seller will estimate the supply volume emission permit, and then submission of bid price and supply volume. And here we have buyer also estimate the demand volume of emission permit and submission of need, and then both will come in term of which the organizer, which is the apps, will determine which winner and winner trading volume for the transaction and the transaction prices. Here we will choose if the participant win the auction, the trade emission will be permitted. If they doesn't, they will come to the end. So means that they don't agree with each other, like that. So the next one is here is the result that I have done. For this one, I haven't done yet any of the application yet, because I still study about the game theory technique and how to do the coding in terms of making the apps. But the idea is there. So for the prediction, here is the result that I have, where I make a correlation coefficient for each input factor and monthly CV grade latex price. So here we want to study which factor that really relate with the CV, and we will choose the most related factor to be used in the prediction of the marketing price for the latex price. So here is the result for the latex price for monthly and daily using different type of algorithm, which is BSVR, Arimax, and PSO SVR, which using three type of kernel function: linear, polynomial, and RBF. So this is RMSE, root mean square error, MAE, and this is correlation coefficient. Correlation coefficient means that the correlation between the predicted data, predicted one at predicted result compare with the real result. So so this is my Gantt chart. For now, I'm still collecting data from Fatma, Madi, and minutes from the we want to get the data from Ministry of Trade and Industry Malaysia. Hopefully by this end of semester, I can get all the data. And I also want to get other data related to the market price. I will try this one. I try for only one crops, which is the latex. I want to try for other kind of crops. For example, like paddy and apa lagi? Oil palm and like the other one, and then maybe try to combine it later, and for other food price also. And here I will try to figure out how to develop a game theory technique. And last, I will do an analysis data and discussion from 20 this analysis data and discussion result will be always be running from the third one, because I want to know the result for this one, and for the rest of it. And the last one is for the seminar, conference, publication, progress, and final report. So this is my references. That's all. Thank you.
Okay, thank you, Caceja. So let's open the Q&A session from your peers. Nobody? Nadira, okay, go ahead.
Okay, Assalamualaikum. Thank you, CJ.
Mhm.
So my question for your research study is, what is your sample size and how much is enough to get a good prediction of output result?
My sample size is depend on my sample size is depend on the data set that I collected later, because right now I still try to collect as much as I can. For now, I got I cannot tell directly how much the data set that I get, but I get from for this one for the market price. I get the data from 2012, I think, until 2022. But the data that we get fully is from 2018 until 2022 data. 2022 data set for the market price, from price, and retail price.
So this is essentially the daily and monthly process.
It's based on daily, but some of the data for that day is not included. So there are some missing data that we need to do some data mining and data cleaning, and it's kind of still in a progress to do a data collection and also a data mining also. Yeah.
Okay, other questions?
Yes,
Okay.
Prof.
I have one question.
Okay,
Yes.
Dr. Mustafa.
Okay, thank you for the nice presentation, CJ.
Yes.
Can you differentiate what's the data mining and data collections? This is my
That
first question. My second question is, what are the constraints of your research?
string. For the second question, I know what constraint mean?
Constraints,
Oh,
some sort of the limitations that
oh,
you will face
limitation
during
that
the data
yeah.
collections.
Oh, okay. So for for the first question, the data collection is as it said, it's more to collected the data from any website or any place, any how to say, any site that can give data set for, like, for example, like Pharma, Mardi, and other like statistic data, apa lagi, and some other agency that can give more data. And if data mining is for me, data mining is like how you process the data. After you collect the data, how you process the data in terms of cleaning the data, the missing value, and then the some of the variable that doesn't match, and you need to fix all that in the data set.
And the
And
research constraint?
research. In my research, the problem are mostly in terms of data collection, because in Malaysia it's hard to get this kind of data set to do a prediction. For right now, I only can get a pharma data set. I cannot get the Mardi, and also the last one, the Ministry of Trade and Industry Malaysia data. They, for this Ministry of Trade and Industry Malaysia, they only can give the latex and also the oil palm data set. And then the second one, my problem in terms of understanding the game theory technique, because right now I'm still learning it. For develop machine learning algorithm, already have the algorithm that I can use for predicting the trading price. The only problem is the data set is still not enough.
And then I have another question. Since the price is not fixed, how can you control the data collection? For instance, about the chicken now, page 11, page 13. For instance, you are
Yes.
talking about the chicken and all the vegetables. Since the price is not fixed, they are fluctuating. How can you play around with these data collections? Do you have any set parameters that you will fix?
Yeah.
Some of the values?
For example, if the you mean that the price is not fixed?
Yes.
For the data, sometimes the price is not fixed because of the unit, right? Is that what you're trying to say?
For instance, like a chicken and the chili hijau, all this pricing will be fluctuate from time to time. For instance, for today, they will give you different price. Tomorrow, they will give you another price.
So that's what we want to see. We want to see how does for example, for the chicken, how does the trend of the price for the chicken. So the next time we will predict the chicken price. So if there too much fluctuation in the for the crops, we will not use it, because it's actually not really good for prediction. But mostly for
Do you have any
prediction,
threshold value?
threshold value, I don't know. I haven't think about it yet.
Okay, thank you.
Okay.
Okay, any other questions from your peers?
I think Mr. Bashir want to ask something.
Okay.
Yes,
yeah,
Doctor.
okay. Go ahead.
I just have an observation because, can you hear me?
Yes, I can hear.
Yeah, I have just an observation. Being your research physics base, as in scientific base research. So in your introduction, just this is from my own point of view. Since you are dealing with algorithm, and the algorithm is the one that is more related to physics, as in more theoretical physics. So I think in your introduction, you're supposed to start with the how you develop the algorithm, or how the algorithm is being applied in solving the market problem, instead of starting with the marketing activity. It seems like it's not in the first place, as I see the work or the research seems like not related to physics. It was later when you go deep, so then I began to see how it is related to physics. And the first impression lasts longer. So to my own point of view, you're supposed to start with the physics aspect, that is the algorithm, how it is being going to be applied to solve the commercial activities. This is just from my own understanding. Thank you.
Okay, thank you for the tips. I will try improve it later.
You want to respond to that?
I because for the first, I think that I want to introduce what is the problem happening in the outside world, and then I try to get more deep and more deep later, and introduce what my algorithm and what kind of research that I want to do in the methodology. I thought that I can introduce it in methodology only, but probably later I will try to put it in my introduction, so everyone can know what my research is about. Yeah, thank you for the tip.
Okay, anyone else? Let's have one more question from the peers. Somebody? Okay, with respect to the game theory, what kind of, okay, essentially there will be some kind of parameters that's supposed to govern the kind of winning strategies or losing strategies. So what do you intend to put inside that sort of game theoretic formulation?
The game theory, I try to put the machine learning algorithm. The prediction that I do will help in terms of the game theory technique, which from the start, every time the like for example the chicken, we will based on the prediction price, we will know that the next day the price is like this. So we will have the price stability in the app. So there will be no like there will be no bias in terms of the price marketing price in the game theory technique. For the parameters, maybe the market price will be the parameters that will be the transaction price that the transaction price and the supply the bid price and the supply volume will be the parameters that I will consider for the
Because as I can see, it's not just mainly on the buying and selling prices, because there will be things like even your transport expenses and things like that. So these are going to be affecting how people put prices, and then how would be the best strategy, I suppose. So you're considering those kind of
Factors.
factors coming
Yeah,
up?
yeah. I will try to consider with other factors. That's why in the prediction trading price we will see other factors that will affect, that will use in for the game theory technique, like the imports, the production, the demands, the supplying, like that.
Okay. So if let me just make the final call. Any more questions from us? I guess not. So I think today we will stop at that. So I will stop the recording now. Please don't go away. We'll take your attendance after this.